Hi there, I'm Hao, and this is just another video of me solving random equal problem. So 5k pair with smallest sums. So we are given two integer array. I need to return k smallest sum, which means all combination between number one and number two. Right. So you can see the result here, right, is the first three pairs, right? K smallest, the first three pair of the sorted sequence. Right? Well, so we can find all, so the naive solution is that we can find all possible pairs, right? And then sort them, or we can even use um, a min heap, right? And then after we add all the pairs into the heap, the min heap, we can uh, we can pull, right, k times to get the k smallest element. But by doing so, gonna give us the time complexity of n square, right? Because we have a nested for loop. So instead of the naive solution, we can still use the heap, right? A min heap. But instead, we have to take advantage of the fact that num1 and num2 are sorted in non-decreasing order, right? So we're gonna have let's see, 1, 7, 11, and then 2, 4, and 6. K is 3. This is our index. And note that the constraint is that there will be at least one element in M1 and M2, right? There's no guarantee that they're gonna have the same length, right? So we can have different length, right? So we can have our index one, right? Index one, and then index two. Okay. So because we are looking for the smallest, the k smallest pair, which means and the array is sorted, right? Both array are sorted, which means the first two number gonna make up the smallest sum, right? The smallest pair. So we can always pick the first pair, right? One and two. So let's say this is our pairs. We can always pick the first pair, right? And then we know that because they are sorted, right? So the next smaller pair. So let's talk in terms of index here, right? Because we're gonna have duplicates, right? There's no guarantee that the value gonna be unique. We don't know that, right? So let's talk in terms of index, right? So we know that the first two index at 0, 0, right, gonna be the smallest pair. So the next smallest pair gonna be either this pair, right, or this pair, like 1, 4 or 2, 7, the minimum of that. And the next one, smaller pair, right, are gonna be so on and so forth. So it's gonna equal to index one, right? Index two plus one, right? Or index one plus one, and then index two, right? So we can just keep instead of iterating the two array, right, in the nested pattern, we can just iterate over it one time, right? And as we iterate, we can add the first and the second index, right? The index pair into our heap and a min heap here. Let's say our min heap gonna start out, right? Gonna start out with the zero and zero pair, right? Every time we pop the index pair, the index pair of the heap, right? We can add it into our resulting pair, right? We can look at the value, right, via the index, right? Right. So when we pop it off, so let's say it is 0, 0, right? So we know that the next smallest pair is gonna be either index 1, index 2 plus 1, or index 1 plus 1, index 2, right? So we can try so 0, 0, right? So index 1 is 0, index 2 plus 1 is gonna be 1, or index 1 plus 1, 1, or 0, right? Which is index 0, 1, right? Or 1, 0 here, right? They have to come from different array, okay? And we also need to keep track of the visited pair. Why? Because the 0, 1 pair here, right, gonna turn into 1, 1, right? 1, 1. So index 1 plus 1 and index 2, or index 1 and index 2 plus 1, right? And this pair gonna have index 1, index 2 plus 1, and uh, and index 1 plus 1 and then index 2, right? So as you can see, we're gonna have duplicates here, right? Right. So that's why we need to keep track of the visited pair of index, because we're gonna have duplicates, right? Like in this special case. Right, visited. And yeah, every time we pop off the heap, which means he pop off from the root, right? And the value at the root is always be the smallest pair, because it is a min heap, right? So for example, 0, 1 and 1, 0 here, right? So 0, 1 is 5, 1, 0 is 9. So the one that will be pop off next at the root gonna be 0, 1. Right? And we can add that to our resulting pair. So index 0, 1. So 0 is 1, 1 is 4. So 1 and 4. Right, right. So it's 0, 1, right? So we need to add a new pair into our uh, heap, right? Which is 1, 1, right? 0, 1. So you're gonna have 1, 1 or 0, 2, right? So on and so forth. So as we can see, 1, 1 here, right, is 11, right? 1, 1 is 11, right? 0, 2, 0, 2 is 7, 0, 2 is 7, and 1, 0, 1, 0 is 9, right? 1, 0 is 9, right? So the next pair that will be pop up is 0, 2, right? That is the smallest pair. This will be at the root, right? 0, 2, right? 0, 2 is pop off. 0, 2 is pop off, right? Yeah, 0, 2. Okay, so we need to add it into our resulting array, 0, 2, right? So 1 and 6. Right, and then we need to add a new pair into our array. So we have a 0, 3, right? And then 1 and 2. So now the length of our pair is equal to k. So we can just go ahead and return. Right? We can just short circuit and return. So we are taking the advantage that both array are sorted, right? So we don't have to try every single possible pair, and that's gonna significantly improve the runtime. So what is the new runtime now? So in the worst case scenario, K will not equal to the total number of pairs, which is m multiplied by n, where m is the length of num1 and n is the length of num2. So we're gonna have O of m times n log m times n, right? Because in the worst case scenario, the length of our heap gonna be m times n, and we're gonna store m times n element, right? So every time we add something, right, that is, we need to swim down, right? We need to heapify up, so that is log of that, right? And the length of the heap gonna be n times n. The space gonna be m times n, right? Because our heap gonna store a maximum of m times n pair. Same for our pairs resulting array. Okay, and that's pretty much it. Let's put this up. So I have a built-in, I have a custom heap here, min heap here, because there's no built-in heap in JavaScript. Feel free to use one in other languages, if you have access to it. Okay, so we're gonna have our pairs array, right? And we will be returning it again. Pairs. I'm gonna have our n1 equal to nums1 length, right? So nums n2 equal to nums2 length. Then we need to visit the set, right? Because there might be duplicate, right, in the special case that I showed earlier, right? And we're gonna start out at putting the 0 and 0 pair, because we know that the first pair, right, the first element in each array gonna be the smallest pair. And we cannot store the array into the set. We have to turn it into a string first, right? And then our min heap, of course, equal to new min heap, right? We can start out at an empty array. Because we already add the first pair into the set, so we need to store this pair, right, 0, 0, and the sum, right? So our format gonna be num1, right? The index from nums1 array, right? Index from nums2 array, and then the sub between them, right? Because we need to be able to compare, right? In heap to heapify up or down, right? We need to keep the priority, right? So the priority here gonna be based on the sum of the pair, right? So that's why I have num1 0 plus num2 0 here, right? And the custom heap also accept a custom comparator function, right? So how do you want to compare it? We want to compare A2 and B2, right? Because this is index 0, index 1, and index 2. Index 2 is the sum, right? We want to compare based on the sum. Okay, so why? So when do we return? We return when the pair of length is equal to k length, right? And y pair of length is less than k. We're gonna pop the pair of the heap, right? We don't care about the sum, right? Which because we always know that the sum is just for the comparison, right? And we know that that we know that, yeah, we know that whatever being popped off the heap gonna be the minimum, right? So that's gonna equal to min heap of all, min heap of all. Right? Then we need to look at the next two pair, right? So pairs one. So we need to add it into our set. So we're gonna make up the key here, right, by doing index one plus 1 index 2, right? That's two string. So this is our key to add it to the set, right? And pair 2 is going to be the opposite, right? Index 1 and then index 2 plus 1. We need to push it into our pair, right? Nums 1 index 1, and then nums 2 index 2. Okay. And then if visited, we only add if we haven't processed the pair, right? So if we don't have the pairs one key, right? Then we're gonna add it add the pair one key, right? And then we do the same for pair 2. Pair 2 key, right? Because and then another thing you need to remember is that the length might not be the same, right? So we need to make sure that the index is less than n1 here, index 1 plus 1, and this one is index 2 plus 2 is less than n2, right? Because the plus 1 here gonna be the new index, right? But this one is also plus 1. If the new index is less than the length, right, which means it's valid. If it is greater than, it is not valid, right? And then we need to push it into the heap as well. So let's call this one next pair 1, and let's call this one next pair 2, right? So we need to create the pair next pair 1. So the first one is the first index, right, from number 1, and the next one gonna be the index from nums 2, right? And the third parameter gonna be the sum, right? Plus nums 2 index 2, and then same right here. It's just the opposite. It is for index 2. It is for index 2, right? And yeah, that's pretty much it. Why the pair is less than, okay? We just keep popping the pair of the heap, right? Push it into our pair and add the new pair into our heap if we haven't seen it yet. And it worked. Thank you for watching.